So how do we control the current that flows through a circuit? The best way is to use resistance. When we change the resistance in a circuit, we change the flow. It makes sense. Let's compare it to water. As water flows through a pipe, and we put pressure over the end of that pipe, resistance or opposition to flow, then that changes how much water is flowing out of that pipe. When we change the resistance, we change the flow. An example is lights. Maybe it's in your dashboard, maybe it's in your headlights, but as we provide resistance to the current flowing, it creates heat, and that heat creates light. Another example of this is a variable switch. This is a variable switch here where we turn the fan faster and slower. As you move this dial to the right, what happens is more current is flowing, and because more current flows over on this side, that means the fan turns faster. The less current flowing means the fan turns slower, and the way that we get less current to flow is we put some resistance in the path so that when current flows through to this part of the circuit, less current leaves to go into the fan, and then we progressively use less and less resistance until it's full current at this part of the fan. Another way that we use resistance and that we get the electricity to work for us and current is in a horn. A horn is a diaphragm, a rubber diaphragm in an enclosed area that vibrates back and forth when we put electricity to it, and that vibration is also caused by resistance. So when you push your hand on the horn, that makes the diaphragm vibrate and therefore makes a noise. And so we need to understand that an increase in resistance results in a decrease in current. When we increase resistance, current goes down and work is enabled. There are a few things that affect resistance, and they lie in the conductor. The first one we'll talk about is the conductor length. The length of a wire changes how much resistance there is. So the longer the wire, the more resistance. You have to be pretty long though in order for that wire, the resistance to change. Another one we'll look at is the diameter. The diameter of the wire. If it's a big wire, similar to something like a battery cable, which is about a centimeter or a little bit less in diameter, that's going to have less resistance. It's going to allow current to flow through it a lot easier than if it is a wire that's the size of your pen. We can compare it to water flowing through a tube. If it flows through a garden hose, it's a lot more difficult to push it through a garden hose than it is to push it through a pipe that is 1 foot in diameter. The next one we'll look at is material. The type of material, whether it's a conductor, semiconductor, or not a conductor at all, dictates whether current can flow through it. So, if we have like copper is a very, very good conductor. Copper allows current to flow through it very easily. Therefore, it has a very low resistance, and that's why they use copper wire in a car. We also want to look at the condition of the conductor. The condition stands for is it damaged? Is the wire, are the little tiny wires inside of the insulation, are they damaged a little bit? Maybe they're torn a little bit. We could also get water damage, and water damage comes from oxidization or rusting that happens when water gets onto the conductor, and that increases the resistance quite significantly. And the last one we'll look at is heat. How does heat affect resistance? Well, heat affects resistance in some types of resistors by increasing or decreasing the resistance as the heat changes. This is a good thing because I'll give you an example right now of how we use this. When coolant is flowing through the cooling system and it's going past the thermostat, we know that there is an electrical sensor there, and that sensor is called the coolant temperature sensor. And that coolant temperature sensor changes with heat, and the resistance changes with heat, and that resistance sends a signal, or the current flowing through the resistance sends a signal to our dash gauges to tell us what temperature our engine is at.